Hey, welcome back to the Build It Basement. I'm Kerm, and this funny looking thing is a Califlower. So we're going to be using this today to do some calibration test on our Trident printer that I built a while back before we print off parts for our box turtle. So I was reading the notes on the box turtle and I noted that it said that you should use one of these before you print the printed parts, so that you can ensure that they go together properly. Wouldn't have thought much of it, but I've had a couple of people tell me they've had issues with those parts fitting together properly. So many P's. And so I figured, why not, you know? So we're gonna go through it. We're going to obviously print it. We're going to go through the process of checking things out and then making modifications to the printer if they need to be made. And we'll go from there. So check out the video. Right, so there are a ton of instructions here. Pull this a little closer to me for this Califlower. So we got some, don't mind the rat rig parts, okay? Different video. Got a lot of things going on. So, yeah, so the Califlower, this guy right here, bottom top. There are little arrows printed on here, one facing up, one facing over to the right. I also put a dot on the front of it from when it was on the printer, so I'd have basically multiple ways to verify because my top surface doesn't look that great. Perfectly usable, but anyways, instruction guide, not installation guide, for the Vector 3D Califlower version 4. And I'm not going to go through this whole thing simply because this is a paid for product from Vector 3D. So I can't give you the STL file. I'm not going to give you all the instructions. And I'm not going to give you the calculating sheet to do this. But if you are interested in doing this, if you're interested in using this, it's inexpensive and it might be a good way for you to calibrate your printer if you choose to do so. So we will look at this briefly here, and basically it goes over and tells you about printing surfaces and measuring tools and filament usage. And pretty much the big thing on that is print this the way that you would print your parts that you're interested in being calibrated. So I tend to print things with 4 walls, 4 bottoms, 4 tops, and roughly 25% infill most of the time. So that's how I printed this. All right, so here is the calculating sheet that they give you, along with a point of reference for all the locations that you're going to be measuring this. So basically what you're going to do is go from, you know, one location to another in terms of where you're going to be measuring. So one's going to be measured on the outside. Let's do that one first. So we got our calipers right here. I'm going to zero them out, and I'm going to zero them out between every single measurement too. So first things first is the number 1. We're going to go ahead and do that. And then take our number. I'm going to try to, I'm going to use the wheel here and try to be as precise as possible. So I get 99.62. And let's just take a couple measurements here to make sure we're on the same page every time. 99.66. 99.62. 99.62. So I'm going with 99.62. So reading 1, I'm going to type in these numbers. 99.62. 99.66 and 99.62. So it's going to give us an average of all those. I'm going to bring my keyboard a little bit closer to me. I don't normally use a keyboard, but in this particular video, we are using a keyboard. So, so that's 1. Then 2, okay, we're going to zero these out again. Bring them back. 2. I have 49.77. So we'll type in 49.77. do it again. Close them up, make sure I'm at 0. $49.85. And then we'll do one more. That last one here. I'm trying to hold this straight. 49.74. The way you slice it, those are all slightly small. All right, number 3. This is our first inside measurement. So we're going to be taking this and we're going to be measuring from the inside of here to the inside of here using our caliper's backside, like so. And here I have 99.77. And we'll do that again. $99.76. One more time. $99.77. Okay, and then number 4 is on the inside of here. So these two. I have 49.83. 49.83. And do that again. $49.9. And then one last time. $49.9. Oops. All right, so we're going to go through and do all the rest of the measurements. So I'm going to time lapse this so it's not an extremely boring video. So yeah, here we go. $59.61. All right. All of our measurements. Let's see here, deviations. All of our deviations here, so they basically say 1 millimeter deviation is within the green, and all of my numbers are much less than 1. Over 1, double check a measurement. 5, deviation warning, steps, large measurement error. I agree with that. So most of my deviations are within 1/2 of a millimeter or 0.2-ish of a millimeter. So my averages are pretty good. I see 99s. Yeah, I don't see 98s where they should be, or 48s. Yeah, so we're good. All right, so results. So our X and our Y are off on my printer. They're off by a decimal of a percent. So basically 0.32 on X and 0.31 on Y, which makes sense that those numbers would be equal or close to equal for each other because this is a Core XY printer, meaning that both motors are used for driving both directions depending on what's going on. So that makes sense. And my skew direction is 90.1 degrees. So I am 0.1 of a degree off for my skew. Inner outer 0.26, 0.37. Fixed skew, note, because of the way Excel works, you may find get switched regional language settings. Okay, so skew direction, so printer config via console. All right, so we have to add on our printer now a skew correction to fix the skew, and then we're also going to have to modify our steps in order to fix those minor corrections. So they're minor, but why not make them, right? So let's take a look at that now. Okay, here we are at our printer, and I don't know how well this is going to work out for me here, because there we go, printer config. So let's go into my printer config. I'm going to scroll all the way down to the bottom, or at least we think we're going to. A little wonky there. And we're going to add a section called skew correction. So right here, skew correction. So let's go ahead and add that after my input shaper. Now yours might not end with input shaper, but pretty much you can put this wherever you want. I'm just putting it at the end because it makes sense for me. So skew underscore correction. And then skew profile load Califlower. So what we're doing here with the code that's listed on here is we're making a profile that the printer is going to load every time it prints based on the measurements we just took. We could disable it or enable it based on what we want to do. So let's go ahead and take a look at that. I'm going to hit save and close here, and we're going to go to the console, which isn't normally how I would do this, and we're going to just copy and paste the code in. So copy, paste, and that information is being pulled from up above. So XY 995978. Yep, that's getting pulled from above. So we're going to send that. And that didn't work because we need to restart first. So let's restart first. Let's go back to our dashboard. And let's do this. Let's just do a, you know what? Let's just do a, let's just do a restart. All right, and we'll just use the console here this time. Let's try that. And that worked because we have that in there. And we're going to grab this one. And basically we're saving that. So what we're doing now is we've set that first code, which is the modification that we're making in the printer. And then we were setting a name to that, which is the Califlower. And now we're telling it to save config, like that. It's going to do a restart. And let's go back into that printer config file real quick. Now let's scroll all the way down to the bottom again. And if you look right here, that's where it added that. So basically we could have, it's not proper by any stretch of the imagination to type directly into this section, which is your save config. It specifically tells you not to edit in this block. However, you could possibly type that directly in there without doing it via the console, but it doesn't make a difference either way. So basically now we have our skew correction in here, which is a XY skew of 0.001805, bunch of numbers, which doesn't sound horrible to me. I'd be interested in knowing if you guys have done this, and if you have, what your numbers have come out like. But we're talking about, you know, almost 2/1000ths of a modification there, which doesn't sound like a lot. That's I think that's pretty decent. Interested in knowing what you say in those comments again. But let's go here now and let's look at our printer. Let's look specifically at our Trident and our machine G code and our start code. So what we want to do in our start code, which is weird here because it says it wants us to load the profile at the end of our start. Oh, at the end of our start. Okay, yeah, get that. I have some edited out things down here, or some commented out things down there. So let's go down here and let's just basically add this. And what that's doing is basically in our start code, it's going to load that modification from our printer. And then our end code, where's our end code? Start code, end code. Oh, I missed it. We're going to clear that. So what we've done now in our slicer is we've added basically a note to the printer to go ahead and load that specific information when it starts printing, and then basically once it's all done to go ahead and clear that information back out. So we're going to go ahead and hit that, and then I'm going to hit save. Yep. And if you have multiple versions of that printer, for instance, this is with a 0.4 nozzle, you'd have to make that modification across all your printers, or across all the settings you have for that one printer. You don't want to copy settings from one printer to another one, much like you wouldn't with Input Shaper. Actually, I have mixed feelings about that, but nonetheless, this is more, I will say this is more specific to your printer than Input Shaper is. So yeah, so that's what we do. Now, that being said, we have to make some additional modifications here, and I need to see what that looks like. So what the results mean: if X, Y both negative, undersized; if X and Y are both positive, print is oversized by a percentage shown. So mine are all negative, so mine's slightly undersized. If your X and Y core are locked, each other average 2 errors. If X, Y, see fixed size below, the skew, fixed skew for X and Y, inner and outer edges. Tips for implementation: ensure your calibration extruder step before doing this test, which we've done. Ensure that your XY steps in millimeters set approximately correct before you do this test, yes. If you have quite large skew error, more than 0.5 of a degree, which ours is not, correct that first between XY composition. Super slicer is only sliced with material XY shrinking composition. If you have Cura, Prusa slicer, Idea Maker, etc., you'll have to use steps per millimeter or rotation distance for the printer instead of, or remember to scale your print for different materials. Interesting. Okay, so we've made that adjustment for our Klipper. And let's see, fix any size. So now in your software, what you're more than likely going to want to do is you're going to want to basically take your parts and scale them. So right here we've scaled these to 100.32, which matches what we had in our original testing for our Califlower. And the reason I did it this way, again, is because different materials will be different. If you did this hard-coded into your printer by changing steps or another method, what would happen is every time you printed, you would have that same number. Now you could get extremely lucky, it's highly doubtful, but you could get extremely lucky and have that be good for every single filament you print. Or if you only print one type of filament for one manufacturer, you might be able to hard code that in as well. But I still wouldn't suggest it. I think you're easier just to change it inside of your slicer software when you're printing out those parts that need to be specifically precise. And maybe keep yourself a note someplace as to, you know, what that looks like. I believe there is the possibility in here, if we go into like generic ASA, that you can put a note right here. So right in here, if you had a specific, you know, if this is my Polymaker ASA profile, I could put a note in here telling me basically to modify for exact performance based on shrinkage to 100.32. That way I can show my parts always the same. Get used to using those notes, but I'm not going to do it today, but just, you know, a little mindful note for you. So I've gone ahead and I've made a copy of the original sheet that we used to take all the measurements. And I've gone ahead and I've marked my original with a 1 in the center and my new with a 2 in the center. I'm not sure if that shows up in camera very well, but so I have a 1 and a 2. And I can tell you that they're very similar. I don't know if visually I can see any real difference between the two, but that's to be expected. They might be able to feel a little difference, but not really beyond that. I can't see a difference. Yeah, I can feel a little difference, but that's about it. All right, so we know how 1 tested out. It's how we did our original measurements. So now we're going to go ahead and take new measurements. And I'm going to overwrite the measurements we had previously so that we can see how they've changed a little bit. So the first measurement we have is our 1 measurement. And basically that 1 measurement is right here. Oh, we have a little issue there with our calipers. Never seen that before. All right, so let's see where we're at here. So before we were at 99.62 and I'm teetering between 100 and 99.9. So I'm going to put 99.99 in here. And then we'll take it again. And we're at about 100.08. I think what's come down to now is pretty much human error. And I'm like a pro at human error, so. All right, one last one right here. So I'm going to take it this way. $99.95. So that one averages out to 100.01. That's really close. Okay, so let's go ahead and take an inside measurement now. That was 1. Let's do 3, which would be up here for 3. I'm not going to do all the measurements. We're just going to do outside, inside, and then maybe the cross as well to see how we're comparing. So yeah, 3 would be right here. So I'm at 100.38. So 3 is at 100.38. All right, we're going to go 100.03. Okay, zero that out and do that one again. $99.97. We'll do one more time. $99.99. Which averages out exactly at 100. That's pretty good. Okay, so we did an outer, we did an inner. Let's do basically do both our X and Y. Let's do this other side here. Do the outer, which is 5. Call it 99.93 on 5. Do it again. $99.91. $99.94. So we're at 99.93 on that one, which is, to me, very acceptable. All right, so we did that. So let's do an inner on that. So we could do 7. So 7 would be between here and here. $99.94 on 7. Do that again. $99.99. I'm going to call it there, honestly, because all these measurements now, I am within 0.01 on average, which means that the adjustments definitely made some differences. And put that in perspective, basically, I've gone from probably about a 0.15 to a 0.2 average of incorrectness to a 0.01 average, or even less than that, average of issue. Last thing I do want to check though is I want to check skew, because remember we changed that inside the printer config. See how that works out. So let's do measurement 9, which is here to here on this. $99.99 for 9. 9 was 99.99. All right, 99.99. And then let's do another reading for that one. $100.01. $99.98. And that averages out to 99.99. So that is our 9. So now it's going to reverse this. Let's do the 10. Almost forgot. 99.92. Okay, zero it out. $99.83. One last time for this measurement number 10. $99.81. This one is seeing the most off. So that one averaged out to 99.84, and according to the sheet, that gives me a basically 0.09 degree skew, and a point, well, we didn't go through and change all the X and Y, so I can't go by what's on there for that. But basically our skew is to, you know, the 100th of a degree, and our measurements from what we tested are to, you know, to the hundreds. So I'm going to say this is very successful. Now, I have not printed my box turtle parts yet, but now that I've done this, I feel a little bit more confident. It's going to be interesting to see how those parts come out. I, again, not had any troubles with parts in the past, but it's good to feel or to know that you're going to be a little bit more accurate when you do print parts after doing something like this. So all in all, quick, simple. I mean, these are about an hour to print, give or take. I mean, you probably get them down to about 45 minutes, or if you're going real slow, it might take you an hour and a half. You're looking at 2 hours of printing, give or take, and possibly about a half hour, 45 minutes of your time to do the measurements and the modifications. So I would say well worth it. Link down below if you want to purchase these. Like I said, it's not too expensive. I think it's about $10, give or take. And you'll be helping out another fellow YouTuber. So you put a lot of effort into it, works really well. I appreciate it, and I think you will as well. So that being said, I appreciate you stopping by, watching the video. If you've watched all the way through, please do give me a like. If you're not subscribed yet, do subscribe. We've got a rat rig coming real soon. It's all these other pictures and parts and all this stuff coming in, as well as the box turtle. So until next time, I will see you soon, and keep printing.